Okay, guys. So we'll continue with production. This time we'll be looking at the long run. So we'll pick a question and see how we'll solve a question in the long run using the Cobb Douglass production function. Okay. So already we know this is the Cobb Douglass production function. Okay. So this is the function, and this is in the long run. Okay. It is a situation where K and L are variable. Okay. In the long run. Okay. But in the short run is only one uh, um, either K or L, which is variable. So it's only one item here that is variable. Okay. So let's pick a question and see how we can solve it under the long run. Okay. So example 1, it says if the output of Kempinski Manufacturing Company Limited is given to be Q equals 10 L to the power 0.5 K to the power 0.5 and wages paid to workers is 8 cedis, where rent is 2 cedis, given quantity to be what? 40 units. Find the optimal labor and capital usage. So in the short run, we only find one item, which is the labor, because in the short run it's only labor that varies. But in the long run, labor and capital varies. So okay, so if you want to find out whether your the question that has been given to you is in the long run or short run, mostly if they tell you to find both labor and capital usage, then meaning you are in the long run. Okay. And sometimes too, the equation itself will give you a clue. So like this, they said that what Q equals, so let's list everything down. Is that Q equals what? 10 to the power L, 10L to the power 0.5. Okay. K, then 0.5. So this is the function they gave us. Okay. And they said that what? Where wages, so wages equals what? 8 cedis. So workers are paid 8 cedis, and rent equals what? 2 cedis. So this is what they gave us. Okay. All right. So we are supposed, and output Q, which is what? 40 units. So this is all we had from the question. Okay. And we are told to what? Find the optimal labor and capital usage. Okay. So to be able to solve this question, okay, first you have to know this formula: MPL over what? MPK equals W over R. So where MPL is what? Marginal product of labor, MPK is what? Marginal product of capital. Okay. Then W is for wage and R is for rent. So wage and rent has been given to us over here. So what is needed is to find MPL and MPK. Okay. All right. So to do that, let's start with MPL. So just like we did with the previous one, where we differentiated L from the Q function. Okay. This one is the same thing that we're going to do. So we say MPL, okay, equals delta Q over what? Delta L, which equals what? So we differentiate this L in the equation. So to do that is going to be, so 0.5 times 10 will give us what? 5. Okay. So it will give us 5L. So when you differentiate 0.5, you have to less 1 from it, which will give us what? Minus 0.5, right? So we are only looking for L in this one. So K remains, so K 0.5. Okay, so we only differentiated L in this equation, so K is not affected, so you just leave it as it is. Then we take this K. Okay, so we did for MPL, which is this, so we come and do for K, so which is MPK subscript K equals what? So we differentiate K from this function. So it's the same thing, 0.5 times 10 gives us what? 5, right? Okay, so now we want K, not L. So L still stands as it is, so L to the power 0.5. Then we differentiate K. So if we differentiate K, it's going to be K minus 0.5 because you subtract 1 from it. Okay, so now we have MPL, we have MPK. Okay, so now let's put these function into the formula, which is this formula here. So it's going to be what? 5L minus 0.5. Okay, K 0.5 all over 5L again 0.5, and K, this is negative 0.5. Okay, equals, so we are this one. Okay, the wage is 8 over 2. Okay, so now that we've gotten here, the next thing is that we have to divide. We divide this over this. Okay, but remember, the rules of indices will apply over here. The rules of indices will apply over here. So if you've forgotten your maths, then you have to go back, okay, and learn. All right, so let's break it down. So this 5 cancel itself, 1 cancel this 1. Okay, so it's left with this L here. So according to the rule of indices, the base letters are the same, so we pick 1. Okay, then we less this, the denominator, the exponent of the denominator from that of the numerator. So we open bracket, negative 0.5 minus what? This 0.5, bracket close. So we do same for the K. Okay, so we pick 1, then this is, we open bracket, 0.5 minus, this is minus, right? So it is minus 0.5. So let me make this one big. Okay, all equals, now this is 8 over 2. 2 cancels itself, 1 cancel 8 how many times? 4, right? So equals 4. So this is what we get. So let's break the top down. So L, so this minus this gives us what? Negative 1. Then this minus this gives us 1. Okay, so we get K, because the 1 we don't write it, equals what? 4. So this is what you're going to get at the end of the day. Now we only want one of the letters here to stand alone, and according to indices, okay, we can further change this to what? Fraction. So if you convert L to the power negative 1 to fraction, you're going to get what? 1 over L, okay, times K. You know this K is multiplying. Okay, so times K. Okay, all right, which equals 4. Okay, all right, so in this state, let's multiply both sides by L so that only K remains. Okay, you can equally let L remain by dividing both sides by K. Okay, but let's make our life more simpler. So we multiply both sides by L so that we find K instead. So we multiply L here and L here. Okay, what you do at the left side, you do the same thing at the right side. So this L cancel itself, 1 cancel this L, 1. So L goes away. So this multiply this gets 4. So we are going to get what? K equals what? 4L. Okay, so this is the function for k. Okay, so now that we've gotten here, we say that wherever k is in the function, which is this function, we put 4l there. So wherever k is in this function, okay, this one, you put 4 there. But already they've given us q to be 40. Okay, so to be able to solve it, you have to put in all the variables. Okay, um so this is how it's going to be. So it will imply that what, our 40 units equals what? So equals 10l to the power of 0.5, right? Now k, we've already found k, and k is 4l. So into bracket 4l to the power 0.5. Know that k rose to the power 0.5, and that is why we have 4l into bracket 0.5. I hope you get it. All right. So then once we've gotten this, let's simplify. Okay. So 40 equals 10l to the power 0.5. Now, you when compute this into your calculator, find out 4 to the power 0.5, and let's see what you get. So if you punch this into the calculator, you're going to get what? 2. 2l to the power what? 0.5. Okay. Know that this is into bracket, so this 0.5 affects both. Okay, so it's to the 4 here and to the L here. So if you are to open up the bracket by applying this 0.5 to both, here becomes 2, here becomes L to the power what? 0.5. Now here too, the rule of indices will apply. So we say that when all the bases are the same, okay, where we have these coefficients, you multiply them, maintain the same one of the base here, okay, then you add the exponent. So it's going to be 40 equals what? So 2 times 10 gives us what? 20, right? Then we maintain one of the variables, which is 1l. Then we add the exponent. So it's going to be 0.5 plus what? 0.5. Okay. So when we add 0.5 plus 0.5, we're going to get 1. Okay. So which means that 40 equals 20l. Okay. So at this side, you can just divide both sides by 20. Okay. So 20 cancel itself 1 here, cancel here 1. Okay. Cancel itself 1 here, cancel this side how many times? 2, right? So we can say that 2 equals L. But then let's turn it in the other way around. So L equals what? 2. So which means that our labor, optimal labor is 2. But here the function said K equals 4L. So then we put 2 back into this. So our K, okay, will be equal to what? 4L, where 4 open bracket, put 2 there. Then so 4, so K is what? 4L. So we put this L into the function, okay, where L is. So we put so K equals 4L, put 2, L is 2, right? So put 2 there, and you're going to get what? 8. So which means that our optimal capital usage is 8, and optimal labor is what? 2. Okay, so to be able to what maximize your profit, okay, to be operating at the optimal um um operation, okay, your labor should be 2 and your capital should be 8. That is all that we are looking at. So in a question like this is what they'll be looking at. So you can then you can finally put, therefore the optimal labor and capital usage are what, 2 and 8 respectively, and then you are done. So that is all for this. Okay. So that is all for this. So at the end of this video, I'll post a question, then you try your hands on it. Okay. So if you don't understand anything, you let me know or you drop it in the comment section and I'll address it. Okay. Aside that, see you in the next video.